Welcome everyone, and today we have the pleasure to hear Anjan Chakravartty from University of Miami. Dr. Chakravartty's work ranges across like philosophy of science, metaphysics, epistemology, merge all those things together wonderfully. And today he is going to talk about, I don't have the title of your talk, so I'm going to let you introduce the title of the talk. I don't remember on the top of my head, but it's a pleasure to have you, and please join me in welcoming him.
Thank you very much. Thank you very much, Eric. I think the title is Constraints on Rational Scientific Disagreement. So thanks everyone for coming. It's great to be back at Western. I have very fond memories of visiting throughout the years. In fact, the very first talk, or one of the very first talks that I ever gave as an invited talk after I started my first grown-up job at the University of Toronto was here at Western. A few of you in the audience are actually old enough to remember that. Or perhaps I should say a few of you in the audience are old enough not to remember that. In any case, it's very nice to be back. So as some of you know, and as some of you have forgotten, but as Eric just reminded you, I have a background in the philosophy of science. I actually have some background in the sciences and consider myself a philosopher of science. But I also have interests in metaphysics and epistemology that often take me into topics that go strictly beyond the domain of the sciences. Those of you who are especially interested in epistemology know that there's been a lot of interest in recent years in analytic metaphysics in the philosophy of disagreement. That is, in the nature of disagreement and its consequences. But I've been wanting to think about this topic from the angle of the sciences for a long time, in part because after reading what various friends and leading lights have had to say about disagreement, I couldn't help but feel that often the cases and considerations that they bring to bear seem too idealized to shed much light on what's really going on in what I personally think of as more interesting, evidentially complex situations. By which I mean the kinds of situations that historians and philosophers of science think about every day, where it isn't especially obvious that there's one right or correct answer or response to the evidence. Now, I've started working on a project that's grounded in some ways in ideas that I've thought about a lot, but that rapidly bring me into very new territory, at least new for me, where my thinking is currently somewhat tentative and aspirational. I should mention that I enticed all of you to come here today by cleverly, disproportionately filling the abstract for this talk with all of the tentative and aspirational bits. Right? But that's just to say that I'll be especially interested and look forward to any thoughts you have about some of the things that I say towards the end, among other things. So, let's dig in. There are a number of motivations for thinking about disagreement in contexts of science in particular. For one thing, as we all know, there can be a lot at stake, especially when our best science is supposed to be used as a basis for making decisions about how we act. For example, in setting public policy and in relation to planning for the future more generally. An obvious example that naturally comes to mind these days is climate science. At least that example might readily come to mind just because of its huge contemporary significance. But in an important sense, that isn't really a very good exemplar of what I have in mind because there really isn't disagreement about climate science. Right? So there's a lot of pretend disagreement about climate science that has been marketed very cleverly in various ways. But the consensus regarding climate science is evident, right? The meta-studies of climate science in which they examine papers in which people have actually taken a view about global rises in surface mean temperature and anthropocentric contributions to that, right, are pretty unequivocal. Now, clearly, the social dimensions of even imaginary disagreement, the kind of thing that climate skeptics peddle, provide ample motivation for thinking about issues concerning things like the public understanding of science and public policy. And these are things that I'm going to come back to a little bit at the end. But let me start with a more specific focus. It seems to me that philosophical discussions of disagreement often proceed as though disagreement is one thing, right? A thing that should ultimately admit of some sort of canonical description. And what people in some corners of epistemology are doing is vying with one another to provide that description. But I suspect that disagreement actually encompasses a number of, and perhaps many different sorts of, cases. And it isn't obvious to me that it makes sense to conflate all of them in trying to give an analysis of the nature and consequences of disagreement. So to give you just one example of the sort of thing I have in mind here, some examples in the literature focus on cases in which one or more parties to a disagreement has clearly misread or miscalculated some aspect of their shared evidence. So, for example, consider the very commonly cited dinner bill case. Right? So, Eric and I decide to go out for dinner. We've agreed in advance to split the bill, but you know Eric, right? I mean, the bill comes, we add it up, right? Eric has some ridiculous number, right, that he thinks that we both owe. At least one person has made a mistake. But now think about what looks to me like a very different situation. Right? Scientific contexts are often, and perhaps typically, characterized by intense scrutiny by large numbers of people of the relevant empirical observations, mathematical models and proofs, experiments, and data analysis. And in these sorts of cases, the evidence, calculations, etc., are commonly agreed upon. What accounts for disagreement in those sorts of cases isn't typically misreading or miscalculation, but rather different interpretations of shared evidence and analysis, where different interpretations don't all by themselves entail that all but at most one party to the disagreement has made an error, right? Or at least so I'll argue. So there's only one right answer to the question of how to add up the numbers on a restaurant bill, but for example, before the detection of the Higgs boson at the Large Hadron Collider in CERN a few years ago, there was no analogous right answer to the question of whether the evidence then available was sufficiently strong to produce belief in it. So I'm going to return to that case a little bit later. So what I want to do today is sketch for you an overview of how we might think about disagreement in scientific contexts. And I'm going to frame this discussion, at least to begin with, in terms of the status of what's often called, after Richard Feldman, the uniqueness thesis. Or equivalently, in terms of so-called epistemic permissiveness, which Roger White is well known for disputing. Uniqueness, as many of you know, is the thesis that, given some evidence, there is, in fact, one rational option regarding what you should believe. Permissiveness is the denial of that thesis. What I want to suggest to you is that genuine disagreement in the sciences generally takes at least a couple of different forms, neither of which is very well analyzed in the terms that are usually invoked in discussions in a lot of recent epistemology. So here are our questions for today. Even among those whom we might regard as epistemic peers, that is, people who share some relevant background, share access to evidence, capacities for reasoning, conscientiousness and deliberation. Perhaps it's a bit of an idealization to think that any two people are exactly the same in all of those respects, but I think often in the sciences we have reason to think that people are pretty close to one another in certain contexts. Even in that sort of case, scientific disagreement is not uncommon. That, I take it, is an obvious and undeniable feature of scientific practice. So how should we think about that? Is there always one uniquely rational option regarding what we should believe? Or are there sometimes different and conflicting, but nonetheless rational options? And what consequences does this have for how scientific knowledge is received in the public domain? Well, let's see. In order to grapple with these questions, let me start by distinguishing two different sorts of cases of disagreement in science. I should point out right away that I take this to be a kind of rough and ready distinction, because strictly speaking, it's misleading, I think, to see them as wholly distinct, right? Non-overlapping categories. In reality, there's something more like a spectrum of cases here. But with that caveat in mind, for what I want to say today, I think it'll suffice to talk about two cases. And you can think of them as admitting of degrees, right, with a kind of fuzzy boundary in between, which is why they form a spectrum. I'm going to call these types relatively transient disagreement, or on your handout, RTD, right, on the one hand, and relatively stable disagreement, or RSD, on the other. So transient and stable, RTD and RSD. So let's begin with the relatively transient kind. As the name suggests, RTD concerns what we might call relatively unsettled science. Why relatively? Well, because in practice, there's no rule according to which, after a given length of time, a given body of scientific commitments counts as settled. And a given theory or hypothesis might be more or less settled, right? Hence the degrees. By settled here, I mean something like accepted by the relevant scientific community as giving a true or approximately true description of at least some parts of the phenomena with which it's concerned. So you might, for example, identify what Kuhn called normal science with settled science, if you like Kuhn's way of speaking, right? And everybody here will know Kuhn's way of speaking, so I don't need to give you a refresher there, but just the idea that there are a bunch of shared commitments among the members of a scientific community. Conversely, there are different ways of being relatively transient, right? And this gives rise to at least some of the degrees of transience and stability that I hinted at a moment ago. So a bit of science might be relatively transient just because it's comparatively new, right? And all of the kinks haven't been worked out yet. Whether it's new or has been around for a while, this sort of dealing with kinks is often exemplified by cutting-edge science, which is at the frontiers of theory and experiment, and by speculative science, which floats trial balloons about things that we're still a long way from grasping. So here's an example of some science that's comparatively new, cutting-edge, and speculative. So many of you know, well, in this room, everyone will know, that one of the great hopes of contemporary physics is for a theory that will unify the four currently known fundamental forces of nature. So on the one hand, we have quantum physics, which unifies three of these forces, right? Electromagnetic forces, the so-called strong and weak forces, which operate at subatomic scales. So it unifies those three forces into a single mathematical conceptual framework. Right? That's three of them. On the other hand, we have relativity theory, which gives an account of gravitational interactions. What we don't have is a theory that unifies the subject matters of quantum physics and relativity theory. And as many of you know, physicists have been hard at work attempting to develop such a theory. So this is comparatively new work in physics. It's cutting edge, and it's highly speculative. Now, there are experts in the area in the room, and certainly, of course, at the university, but I'm sure everyone here has heard of string theory, right? Perhaps loop quantum gravity. Right? These are different approaches to unifying the four fundamental forces of nature, and this work is far from settled. Right? Physics itself, I mean, physicists themselves regard this theorizing as transient in my sense. What's interesting from my perspective, and from the perspective of thinking about disagreement more generally, is that there's huge disagreement here among scientists between advocates of different approaches and the resulting theoretical descriptions. I think it's a great example of what I'm calling RTD. And what I want to suggest to you is that while this is clearly an example or an instance of disagreement, and in science, it isn't really the sort of thing that fits very neatly or easily into the usual mold of discussions of disagreement in contemporary epistemology. The reason for this is that the disagreements, or at least a lot of the disagreements at issue here, are often difficult to analyze in terms of contrary beliefs. In cases of RTD, the appearance of disagreement about scientific facts is often superficial. Right? It may look on the surface as though rival scientists have contrary beliefs about facts. But on further scrutiny, it often seems more plausible that what's in play here are attitudes other than belief. So in RTD, there are certainly contrary hopes. I mean, advocates of string theory are hopeful that they'll be able to come up with a workable model of quantum gravity. There are best bets, right? You might put your money down on one approach or another approach to deliver the goods in due course. There are definitely heuristic commitments, commitments to explore where a given approach may lead. But none of those attitudes, right, hopes, best bets, heuristic commitments, are properly described as beliefs, at least not directly concerning conflicting putative facts about the world, which I take to involve something more like a commitment to the truth or the approximate truth, which none of these attitudes would appear to entail. So if I'm right about this, then RTD, relatively transient disagreement, often doesn't represent an epistemically worrying category of scientific disagreement, or at least not generally. Of course, it might be worrying for other reasons, right? So say reasons having to do with debates about how science should be organized or conducted or funded or used in setting policy. But it isn't well described by much of what we currently call the epistemology of disagreement. Okay, let me turn now to relatively stable disagreement. In cases of RSD, as I suggested earlier, we're concerned with instances of relatively settled science. Recall that being settled here has something to do with a scientific community's recognition of a theory or a model or a hypothesis as being true or approximately true. What's interesting about these cases is that even though the relevant science is recognized as being relatively settled, we still find disagreements among scientists. Right? And this is because even when a given body of theory, etc., is accepted as true or approximately true, I'm just going to leave that qualification and take it for granted from now on. Even when it's accepted as true, there are different ways of interpreting what exactly is right about it. So let me give you an example of how this can occur, just to illustrate the idea that one and the same body of scientific theory or practice can be multiply interpreted. So consider the standard model of particle physics, which describes a taxonomy of particles composing matter at the subatomic level. Right? This is one of the great achievements of 20th century physics. It was fully formulated in the 1970s. Earlier, I mentioned the Higgs boson, the last holdout from experimental detection of all of the particles described by the standard model, which was finally detected, right, at CERN in Geneva a few years ago. A lot of us would know this professionally, but of course it was in all the newspapers as well. Right? There's consensus in the community of physicists that the detection was successful. But now consider the period between the formulation of the standard model and the experimental detection of the Higgs particle. Over that duration, I think it's fair to say that the theory was accepted by the relevant scientific community. And by that I mean that at a certain level of abstraction, right, in a sort of coarse-grained sort of way, and in lots of fine-grained ways too, particle physicists generally shared the commitment that the theory is correct. And yet, there wasn't exactly unanimity about all aspects of it. So as I say, I think that physicists generally believe that the theory is basically right, but the fact that the Higgs particle hadn't been detected yet yielded what I think is a very interesting variety of doxastic attitudes towards that particular part of the overall theoretical framework. So some firmly believed in the existence of the Higgs, others were less willing to commit. There's actually some nice, I suppose you'd call it sociological research, or social science research that was done on this by our colleague Michael Stolzner and particle physicist at the University of Bonn, Peter Mattig. And what they did was they actually asked, I think they had questionnaires, and they asked physicists working at CERN about what their doxastic attitudes were towards the Higgs particle before the experimental detections, right, in that period leading up to it, and then afterward. Right? And beforehand, there was this interesting spread of doxastic attitudes. Right? Some people were firmly committed, other people were less committed. You know, some people were really hoping that it wouldn't be found. That might usher in a new age of physics, right? And there are all kinds of interesting attitudes. And then after the detection, within a very short period of time, when consensus kind of manifested around the idea that it was successful, all of these interesting doxastic attitudes just collapsed, basically, into belief. Right? So here's the point that I want to extract from this example. In that case, there was clearly some disagreement about the Higgs boson. But I don't really think that this disagreement took the form of contrary beliefs. Right? That is, beliefs in conflicting putative facts about the world. Right? Beliefs in the existence of the Higgs particle on the one hand, and belief in its non-existence on the other. Right? Rather, the disagreement took the form of a contrast between belief on the one hand and suspension of belief, or agnosticism, on the other. I think that this difference between contrary beliefs on one side and belief versus suspension on the other is actually important. So let me try to explain why that's so. So how is it that different scientists who broadly accept a given framework for describing some aspect of the world end up with different doxastic attitudes, right, in the form of belief and agnosticism towards some propositions embedded in that framework? In discussions of disagreement in philosophy, there's a significant amount of attention given to the question of how different doxastic attitudes can arise, even in the idealized scenario of epistemic peerhood. What a number of these accounts have in common is an appeal to commitments that underlie the relevant doxastic attitudes. That's to say that different agents sometimes have different underlying commitments, and it's these underlying things that are ultimately taken to be largely responsible for the manifestations of the different doxastic attitudes. So insofar as they have sort of this much in common, I take various proposals to this effect in the literature to comprise a sort of family of views. Right? So let me just gesture toward a few of these views that I have in mind, which many of you will know. If you work in epistemology, you will have come across them before and you may know them very well. Robert Fogelin suggests that in cases of what he calls deep disagreement, there are, and I think I gave you this quotation on your handout, there are underlying principles that serve as the ground for reasoning to the effect that an argument is compelling. So he characterizes these principles as constituting beliefs, preferences, and procedures for resolving disagreements. He likens some of them to what Hilary Putnam calls framework propositions. And he invokes Wittgenstein's idea of hinge propositions. Right? So here's the famous quote from Wittgenstein. Right? The questions we raise and our doubts depend on the fact that some propositions are exempt from doubt, are, as it were, like hinges on which these turn. And another one, because it's always fun to quote Wittgenstein. Right? It belongs to the logic of our scientific investigations that certain things are indeed not doubted. Now, for those of us who work in the history and philosophy of science, this has a special resonance in some history of philosophy of science, where a significant amount of attention has been given to neo-Kantian approaches to scientific knowledge. So think of Michael Friedman's discussion of constitutive a priori principles, or David Stump's discussion of functional a priori principles. If you're not familiar with this, don't worry. The details aren't crucial here. The basic idea is just that there are some propositions that are foundational for the relevant science. And this is one kind of example, I think, of possible hinges. But there's something unsatisfying about all of this, which I think some people have noticed. What's unsatisfying about this family of attempts to ground disagreement in some framework propositions or hinges is that it's really unclear, I think, on reflection, why these underlying things should serve as any ultimate sort of ground. In other words, it's never really clear why these underlying commitments aren't or couldn't be subject to debate as well, possibly leading to a resolution in favor of some shared set of underlying commitments or principles on which to build up the relevant beliefs. Or alternatively, leading to a perhaps a regress of things about which we might disagree, right? We might not have any consensus at all. Right? That's what Feldman argues, for example. He suggests that parties to disagreement may, through this kind of reflection and engagement, rationally come around to agree. There doesn't seem to be anything in Wittgenstein or Putnam or Vogelin to preclude reasoning about the underlying commitments. You might reflect on what arguments support them, what the premises in those arguments are, etc. So let me put some cards on the table now myself. I think that the idea that there are underlying commitments of some kind that are responsible for relatively stable disagreement in scientific practice is right. But crucially, I don't think that these commitments are typically amenable to reasoning in the way that Feldman and others suggest. The key to understanding this better is to better articulate what these underlying things are exactly. As I mentioned, Vogelin characterizes them in terms of beliefs, preferences, and procedures for resolving arguments. But beliefs, procedures, and preferences, it seems to me, are very different sorts of things. Right? I think that Vogelin is partially correct. Right? Where he goes wrong is in identifying beliefs as part of the relevant underlying stuff. Right? And since Wittgenstein and Putnam and others likewise talk about underlying propositions, I take it that what they say has also likewise gone wrong, since of course what they have in mind is belief in those propositions. Now, in addition to beliefs, Vogelin also mentions preferences and procedures, and here I think he's onto something, though he doesn't really elaborate on those latter two things at all. What are they? The key to understanding what lies beneath, I want to suggest, is to recognize that it really isn't propositional per se, which is to say that it really isn't susceptible to belief. Here's something closer to the mark of what I have in mind. So Earl Coney argues that epistemic peers sometimes differ in their intuitions, that is, their perspectives on reasons and evidence regarding the appropriate doxastic attitude to take towards a proposition, which then serves as the basis on which they can rationally disagree about that proposition. And likewise, my former colleague at Notre Dame, Robert Audi, notes that some of the contributing determinants of belief are merely causal and not justificatory, right? In the sense that they aren't strictly relevant qua evidence to the truth of an assertion, whether they're conscious or unconscious. Right? So just to recap, right, summarizing these people who I think are barking somewhere near the right tree, here's what we've got, and it's a bit of a mouthful, so I put it on your handout, right? What we've got are conscious or unconscious intuitions or perspectives on reasons and evidence that underlie doxastic commitments, but that aren't themselves propositional or evidential. That is a mouthful. And I don't think that any of the authors that I've mentioned here really spell this out. But one of the things that I try to do in a book that some of us discussed yesterday is to describe what I think these underlying things are exactly. I call them epistemic stances, and I see them as being essential to the kinds of ampliative inferences that we typically find in the sciences and elsewhere. That is, inferences to conclusions of the sort that exemplify the phenomenon of relatively stable disagreement that I described a little while ago, where disagreement takes the form of a contrast between belief and agnosticism regarding certain scientific claims. So to give you a flavor of this, which will bring us up to the aspirational thoughts that I want to conclude with, let me sketch an example of how epistemic stances can function to bring about different doxastic commitments in relation to a given domain of scientific claims. So as I mentioned to some of you yesterday, interpreting scientific theories and models inevitably involves some degree of what I'm going to call metaphysical inference. Now, I appreciate that some scientists, and some philosophers for that matter, people who are inclined to interpret science in ways shaped by certain forms of empiricism or pragmatism, may not like the term metaphysical inference because they're allergic to the very idea of metaphysics, and I understand that. But I actually intend the label here in a fairly innocuous, hypoallergenic sort of way, right? Reasoning to the truth of scientific claims, the process of making inferences, has an a priori dimension. Right? It inevitably makes recourse to at least some non-empirical considerations, not merely empirical or a posteriori considerations. So commonly, the largely non-empirical considerations involved in making metaphysical inferences are explanatory. They're thoughts about how best to optimize the sorts of features that we commonly associate with good explanations. So, a good metaphysical inference is generally conceived as one that yields a good, ideally the best that we can produce, explanation of the data. And the criteria most commonly associated with explanatory goodness are things that you all know, right? Things like simplicity, internal consistency, coherence with other knowledge, our background knowledge, the scope of the phenomena that are unified by the explanans, all of those good things. The a priori character of this reasoning is manifested, for instance, by taking seriously our intuitions about how best to optimize and rank and weigh those sorts of explanatory virtues. What sets metaphysical, a priori, non-empirical reasoning apart from non-metaphysical, a posteriori, empirical reasoning is the extent to which our inferences are fueled by or informed by or sensitive to observation and experience. So there's something like a spectrum here ranging from lesser to greater magnitudes of metaphysical inference in the interpretation of scientific theories and models. At the minimal end of the spectrum, there are claims that follow from, say, using our unaided senses, concerning the observable phenomena, pointer readings on instruments, and so on. Further along the spectrum, there are claims about how you might detect things using instruments and techniques that putatively extend our epistemic reach beyond the use of our senses. So you might, for example, use a light microscope, the sort that everyone here used in high school. Actually, some of you here, I'm not sure what they're using now in high school, probably scanning, tunneling electron microscopes. They probably use light microscopes in preschool these days, I'm not sure. But in any case, right, you can use those kinds of technologies to putatively examine microscopic organisms. And that presumably involves a lesser degree of metaphysical inference than reasoning about what you might infer using a particle accelerator at CERN, right, putatively to probe the natures of the smallest bits of matter. And there are claims that are even further along this spectrum, right, regarding things that we can't even putatively detect at all, but that we postulate for explanatory reasons. So this is what I have in mind by the spectrum of metaphysical inference in science. All of these inferences incorporate some empirical information in the form of observations or empirical data, but then what happens is more broadly an interpretive exercise in which we determine what these observations and data can tell us about things that putatively underlie them. The issue that I want to flag is how trade-offs between different factors that are relevant to assessing the quality of a metaphysical inference actually play out in scientific judgments about what should qualify as genuine scientific fact. So for example, consider the idea of novel predictions that are borne out, right? Predictions of data that weren't previously known, or that were known but weren't actually taken into account in building the relevant theory or model. It's commonly held that theories that make these sorts of predictions are more vulnerable to empirical investigation than theories that don't. So when novel predictions are then borne out in observations and experiments, the relevant theories are regarded as having passed a kind of test that lowers the epistemic risk associated with them. That is, the risk of being wrong when taking something to be true or false. So successful novel predictions are generally thought to lower epistemic risk. That's just one example of a factor that I take to be relevant in assessing risk. Let's call that factor empirical vulnerability. The greater the empirical vulnerability of a theory or a model or a hypothesis, the better the quality of the associated metaphysical inference. To take the converse of this, when theories make no novel predictions, but only predictions of data that were already known and taken into account in formulating the theories themselves, I mean, in some cases, as we know, theories are formulated precisely so as to make certain predictions. Well, in those cases, empirical vulnerability is lower, right? And then there's no comparable lowering of epistemic risk. So you might, based on what I've said so far, think it a straightforward thing simply to judge candidate facts that are implicated in impressive novel predictions, which come to pass, as genuine scientific facts in virtue of empirical vulnerability. And by the same token, you might judge candidate facts that are proposed merely to accommodate some already known data less favorably. But as we know, in scientific practice, that isn't what happens as any sort of rule. And there are good reasons for this. I mean, well, as an aside, for one thing, there's at least some controversy about whether evidential relations between data and theories are sensitive to this distinction between novel predictions and accommodation that I've just used as an example, but I won't worry about that today. Right? What I will dwell on for just a moment is just the idea that if you grant the power of novel predictions that are subsequently borne out in scientific practice to reduce epistemic risk, which actually I suspect is the right thing to do, we haven't yet factored in here another important criterion for what's often used to assess metaphysical inferences, namely explanatory power. If the explanatory power of a theory or a hypothesis in relation to the relevant empirical phenomena is sufficiently great, it sometimes reduces the epistemic risk involved to such an extent that it might counterbalance or in some cases even override considerations of novel prediction versus accommodation. So there are plenty of examples of this, I think, but again, just as in the case of empirical vulnerability, there's no straightforward or unequivocal rule that determines the relative impact of explanatory power on epistemic risk. So for example, the awe-inspiring unificatory power of the idea of natural selection in evolutionary biology, which brings just a huge wealth of data, right, from paleontology to population genetics into a common theoretical framework, is undoubtedly, I think, one of the major reasons for its acceptance as fact. And that's true despite the relative inefficacy of the theory for making precise predictions, right? It just turns out that it's very hard to make those kinds of predictions because of the uncontrollable effects of various other biological processes that are involved in evolution. Nevertheless, unification, remember, is one of the hallmarks of good explanation, and it's powerful. But even the amazing unifying power, and thus explanatory power, not to mention predictive success, of the Standard Model, collecting electromagnetic and strong and weak nuclear interactions into a single framework, even that was insufficient to convince some scientists of the reality of the Higgs boson before its detection a few years ago. So what I want to suggest to you is that these judgments about what to believe and what to be agnostic about, driven by assessments of factors like empirical vulnerability and explanatory power, are indefeasibly in the eye of the beholder. Now, in saying this, I'm not suggesting that anything goes, right? Surely there are some plausible, if I think, relatively minimal constraints on what may count as rational belief, and I won't say more about that now, but I'm happy to come back to it later. The point here is simply that judgments about where to draw lines between belief and agnosticism turn on the different epistemic stances of agents. And this is what we mean, I think, when we find ourselves sputtering that mouthful that I put on your handout that various people have alluded to, right? That there are some conscious or unconscious intuitions or perspectives on reasons and evidence that underlie doxastic commitments, but that aren't themselves propositional or evidential. All right, so in conclusion, I'd like to draw a few tentative morals from all of this thinking about disagreement for thinking about how, for some time now, in the Western world and beyond, scientific knowledge has been under attack in the public domain, with the many unfortunate consequences that that brings. The reasons for and strategies of these attacks have been well documented by scholars in HPS and in STS. They include all of the special social, economic, political, ideological interests and lobbies that all of you are very familiar with, perhaps in part through that scholarship. I began today with the observation that even among those whom we might judge to be epistemic peers, or at least close enough, there's often scientific disagreement. Now, if you want to undermine a body of knowledge, nothing is better than showing that even the purveyors of this knowledge don't agree about what that knowledge is. Of course, a lot of science denialism takes the form of people fabricating pretend disagreements. This has been the focus of a lot of the studies that I just mentioned, right, where what we find is a series of concerted efforts to orchestrate mass lying campaigns about, say, scientific consensus and, about all sorts of things, about the harmful effects of tobacco, about climate change, and so on. All of this is about the marketing of pretend disagreement. But as I've suggested today, there are plenty of genuine disagreements between scientists about scientific knowledge. Just as in the case of pretend disagreements, though, I don't think that any of this is properly leveraged into an argument for skepticism about science, right? Or for science denialism. Appreciating the reasons for this, I think, require not just a better understanding of science than we typically find in the public domain, but actually a better understanding of the philosophy of science than we typically find outside of departments of philosophy, right? And that's a problem. Right? So let me come back to that problem in just a moment. Firstly, why is it that genuine scientific disagreement isn't properly a premise in an argument for skepticism about scientific knowledge in the public domain, for purposes like, informing public policy making? Well, if scientific disagreements can be rational, doesn't that open the door to some kind of debilitating relativism, right, ripe for exploitation by science denialists? I don't think so. So consider relatively transient disagreement. Arguably, a lot of apparent disagreement in science isn't really about knowledge at all. It's about a variety of non-doxastic attitudes and commitments, hopes, best bets, and so on. There are always going to be parts of science that are heavily under construction, but even there, right, even those places where we're working at the cutting edge, the empirical data and results that we're grappling with often aren't in dispute. So often even disagreement where it takes the form of these non-doxastic attitudes is working with and premised on a whole bunch of information that is shared across the people who possess these contrary non-doxastic attitudes. Consider relatively stable disagreement. Here, there really are conflicting doxastic attitudes, where the typical conflict, as I suggested earlier, is belief on the one hand and suspension of belief or agnosticism on the other. But here, too, the empirical data and results really aren't the subjects of the relevant disagreements. Given the data, different interpretations of the relatively settled science are possible, because armed with different epistemic stances, and thus different assessments of the interplay between empirical vulnerability and explanatory power, different interpretations may follow. So there's no unique prescription or algorithm for how to make those assessments in a rational way. But none of this leads to the kind of epistemic relativism that I think is worrying in the context of making decisions about public policy. The worrying sort of epistemic relativism is one according to which, say, you believe a proposition P, and I believe not P, and there's nothing more we can say about that situation, right? Qua rationality. That's to say that contradiction is sanctioned by our norms of rationality. And rationally sanctioned contradictions make people nervous. I'm sympathetic to that reaction. Rationally sanctioned contradictions really could be an impediment to debating public policy. But what I've described here today isn't relativistic in quite that way, where someone adopting a less conservative stance with respect to metaphysical inference might be tempted to affirm certain propositions, say, regarding all kinds of unobservable objects, events, processes, mechanisms. And the holder of a more conservative stance doesn't deny those claims. Rather, she has no beliefs at all about the truth values of those propositions. So on the one hand, one person affirms, say, the existence of quarks and descriptions of their properties. The other doesn't deny those things, right? The other simply remains agnostic. And in that sort of way, the latter person's beliefs may simply form a subset of the former's, right? And crucially, the one thing that will be shared across all of these different possible sets of belief are beliefs about the empirical consequences of the theory. And that's exactly what we need to agree on in the context of forming and enacting public policy. So there's, I think, a lesson in all of this, a lesson for how we think about education. I mean, it's not uncommon to hear kind of plaintive, mournful cry that if only we did a better job of educating people about science, it would be harder for denialists to manipulate parts of the public. I'm sure that there's something right about that. But it can't be the whole story. Right? I mean, climate models, just to take that topical example, are extremely complicated. Right? I mean, there are lots of different difficult decisions to be made about how we parameterize them. Right? We need to incorporate all kinds of idealizations in order to make them tractable at all, right? And so on. Right? It's really messy when you start to dig into it. The point that really needs to be understood about climate models so as to not be prey or to be less prey to superficial skepticism about them isn't, in the first instance, all of the relevant details of the science, right? That's really asking a lot. Rather, it's a relevant detail about the philosophy of science. I mean, what's so impressive about climate models is that despite the different parameterizations and idealizations across the different simulations, the results in terms of empirical predictions are amazingly robust. In other words, I mean, just to caricature a little bit, they all say the same thing, right, about the predictions that they're making with respect to, say, the increase in mean surface temperature rise over the next X number of years. That's an amazing fact, right? A fact about consilience, I think, with an obvious epistemic moral. A graduate student of mine, Corey DeChair, is right now working on the concept of robustness in this context, and one of his case studies is climate models, right? So stay tuned. The relevance of consilience and robustness for the epistemic upshot of a theory's predictions about the empirical phenomena is a much more accessible fact about confirmation than the scientific details of climate models will ever be. Of course, what I'm saying isn't new, right? But I think it's something that has been lost and needs to be refound. It was abundantly clear to the logical empiricists when they dreamed of the unity of science. When I was taught logical empiricism the first time, it was all about the semantics of theoretical terms and the verifiability criterion of meaning. Right? That was it. The entire motivation for the most important philosophical movement of the late 19th and early first half of the 20th centuries was left out of the picture completely. Right? The idea that the sciences, in virtue of their empirical adequacy, could be marshaled to make the world a better place. Right? Perhaps the rationale behind the way I was taught about this the first time stemmed from the idea that the motivations of the positivists are separable from their philosophy. And it's the philosophy that should be taught, right, in the philosophy seminar. But that's entirely mistaken, right? The motivations are inherently philosophical. It's in the motivations that we see how the kinds of genuine and perfectly rational disagreements that I described in cases of relatively stable disagreement are compatible with shared commitments regarding the empirical consequences of our best theories. And it's the latter that's crucial in contexts of public education and policy. So, I don't myself have a recipe in my pocket for how we might bring about the educational utopia in which our systems of education will instill not just better understandings of science, but better understandings of the philosophy of science, right? Thus rendering the public less susceptible to skepticism about science. But when that day comes, it will surely involve a better and richer understanding of scientific disagreement. Thanks a lot.
Is there time for questions?
Thanks for that. That's so rich in lots of different ways. Let me ask kind of a basic question. So this, at least at first glance, looks like a pretty compelling picture of kind of varieties of disagreement in a science with unifying hypotheses, like physics, like evolutionary biology, which were your two main examples. Do you have thoughts on how well this also applies to sciences like psychology or neuroscience, that are, if not disunified, at least ununified? Right, where disagreement is somehow much more local or something like this?
Yeah, thanks a lot for that. I think that's a really important question because that is actually a lot of our science, right? It takes that form. So I suppose that there are a couple of things that I might say about that. I mean, one of them is that in order to locate, I think, where we are on what I described as a kind of spectrum of cases from relatively transient science to relatively stable science, right? I think we need to do that by examining specific cases and then figuring out where we are in any given case. And it may be that in some of these disciplines, we're closer toward the end of the spectrum that we might call relatively unsettled science, in which case, we might want to realistically and without fear just examine what we take the state of knowledge to be in that field, right? Is it something that we expect to be unified? Is it something that admits of a unificatory project as a kind of regulative principle, right? And if so, how far advanced along that trajectory is it, right? It may turn out that in some of these fields, that isn't really on the cards at all. And then I think what we often find is that different subdisciplines that are collected, in the same pockets of science are really asking different kinds of questions. And then I think they're really dealing with different, to use the scholastic terminology, different natural kinds. I mean, they're actually carving up the world in different ways to answer different kinds of questions. And so in those cases, the appearance of disunity on the surface is really kind of misleading. There's nothing there to be unified per se, because each of these subdisciplines may be pursuing certain questions and may be quite advanced in their trajectories of producing knowledge regarding those particular things. So I think we kind of have to look at it on a case-by-case basis to see where we are along the spectrum that I've described.
Yeah. Just a quick follow-up on that.
Yeah.
Then you raise this, then starts to point towards a kind of relativism that's different from, but related to the relativism you want to disavow at the end. Yeah,
I don't think it does. But I know that in some of the contemporary literature on scientific pluralism, people suggest something that sounds very much like that. So they might say, look, there are different conceptions of certain, say, psychological categories or cognitive categories that are given to us by different kinds of scientific methodologies, right? And that what this gives us is a kind of pluralism, right, about the relevant psychological things. So the example that's popping into my head right now is Helen Longino's book about studies of human sexuality and aggression. She says, look, there's certain concepts, and we have these very different ways of approaching the study of those things. And she says something that I think is telling, that leads to a conclusion that's different from the conclusion she draws in the book. The conclusion she draws is that we need to be pluralistic about how we understand the different accounts of one and the same phenomenon, right? That all of these different approaches are tracking in some way. What I want to say is that to the extent that, to use her language, these different approaches are parsing the causal space differently, right? They're actually dealing with different things. I mean, if you have different collections of causal parameters, right, that are emphasized or taken into account in these different contexts of scientific work, that's what I mean by they're actually dealing with different natural kinds, right? So it might be a mistake to think that they're all talking about the same thing. And they might be quite well advanced in shedding light on whatever it is that they happen to be tracking. Of course, it might not be until the whole constellation of science in that area is further developed that we see whether there are ways of amalgamating some of these approaches or not, whether the concepts can be unified or not, right? But I take that to be a separate point.
So Jenny, and then Chris.
Thanks.
So one question, something you didn't talk a whole lot about when we're talking about structures of scientific communities and disagreement therein, is that different agents are situated in different ways that have different access to information in all sorts of ways in terms of who their colleagues are and resources at their department and all these sorts of things. Mm-hmm. So given the case of the Higgs boson is a bit of a strange one in a sense, in that cases of big science don't have these problems as much because there's this general project that everyone's kind of working towards. But in a lot of cases of just scientific communities that are geographically dispersed and dispersed in all sorts of other ways, it seems like a lot of cases of disagreement you can talk about just in terms of not everyone having the same access to the same kind of evidence or something like that. So if that's right, then it seems like talking about it in terms of stances might be only true in some cases when trying to make advice for public policy or something. So I was wondering if you could just have some remarks on that.
Yeah, absolutely. So I think that's a very nice point, right? Which is that one of the idealizing assumptions of what I've kind of abstracted from the literature and epistemology, right? That to hold one factor fixed, right? We'll assume that the relevant people that are disagreeing with one another are epistemic peers, right? By which we mean, they share the relevant background knowledge, they have equal access to the relevant data, they have the same sort of computational, right, abilities or other relevant abilities to assess the data. They're equally conscientious, right, in how they deal with the data. When you hold all of those things, right, fixed, then we might still get disagreement. That idealizing assumption often doesn't hold in practice, right? I said, I think just in passing, that there are scientific contexts in which even if we think that idealization is never actually realized, there are contexts in which we might think that the relevant scientists are close enough that we can make that idealizing assumption without it being problematic. By the way, I think that the problem is real, and it may be even more real than you think, and that I'm not even sure that it's the case that in big science, right, everybody should be judged an epistemic peer or close enough in the terms I just described. Just because in very big science projects, right, this is a point that's been made in epistemology, but also in social epistemology, there are people who are working on different aspects of these projects that often have very different conceptions of what's going on. They all bring something to the mix, and they need to collaborate in order to get it work. That's part of big science. And so, what comes to mind here is Peter Gallison's work, where he says, look, there are these different cultures of physics, and when you get big projects, you have experimentalists working with theoreticians, working with instrument makers, and their conception of what's going on may be quite different, and they need to figure out ways to communicate with one another, and that's what he focuses on. But what's interesting here is just the idea that they may not actually be epistemic peers in quite the sense that I described here. So it may well be the case that the problem is more pervasive than even you suggested. So I think that's a real issue. The extent to which what I said would apply is really premised on this best case scenario where we've identified a group of people who are in this optimal situation of all being as maxed out as possible on all of the parameters that I just suggested define epistemic peerhood. In real life, things aren't that way. Ideally, what do we do when we form public policy? Ideally, but this is another idealization, we consult that subset of people that we think are as close to maximally informed in all of the ways that we described as definitive of epistemic peerhood, right? And get their opinion. Not everyone's opinion, but even there, as I said, that's an idealization. And even if we are successfully able to de-idealize that particular idealization, we still have the phenomenon of disagreement that I've described. So, in other words, what I want to say is that even in the best case scenario, we're still going to have these kinds of disagreements, but there are mitigating factors, right, when it comes to thinking about public policy that should not lead us to, or allow for the generation of skeptical arguments on the basis of that kind of differential interpretation. That's what I want to say.
Just a very quick follow-up.
Yeah.
This is related to this business right here. I was just thinking of the problem of communication. Harry Collins, who used to overemphasize this, but he was on to something about replicating experiments. And often people couldn't communicate how they carried out the experiment. You had to go to the other guy's lab and live with the guy and fiddle with it, and you took home something that was non-propositional. You took home a skill.
Right.
And that's got to be part of the bargain too.
Yeah. I think that's absolutely right.
Sorry.
Yeah.
No, so that's what I was going to say. I mean, when you were talking about what's involved, you talk about conscious and unconscious processes, but then the procedural part seemed to fall out of the picture. And I mean, you bring back in terms of observation and techniques, but I mean, what role is it playing in those?
I think it has to be playing a significant role, right, for the reason that Jim just mentioned. Yeah. And to be honest, it isn't something that I've thought about a lot, right? I mean, I think there's a reason that the replication crisis has demanded so much of our attention recently, right? I think these are serious issues. And I do think that a lot of what's at stake with respect to agreement and disagreement here concerns things that are, maybe for lack of a better term here, knowledge how as opposed to knowledge that. So they're going to involve all of the kinds of tacit abilities that scientists learn in the particular context in which they're trained. Right? I think that should be compatible with the morals that I want to draw here, but I haven't fully worked that out. Yeah.
So I'll go back to mine. I think Chris was next.
So I had a similar response to a lot of the analytic epistemology, the literature on disagreement that just doesn't seem to track real cases of scientific controversies. And I'm interested, I think this runs really in close parallel to the arguments you were giving, but one of the reasons I think it doesn't track well is that we just don't know what our theories say that well. So typically we don't have enough understanding of what the theory would say about the world in order to have beliefs about our conflicting theories that would also be in direct conflict. So we often have very specific calculational things that we can do for conflicting theories, and often those don't overlap. So if you ask what string theorists can calculate, for example, they can calculate the entropy of black holes, but those are extreme black holes. Those are different than the kind of black holes that people can calculate the entropy for or claim they can calculate it for under quantum gravity. And so you have different calculations that are in some ways similar, but are actually about different things. And then more generally, what loop quantum gravity can calculate, what it's easiest to calculate in that context is usually just completely non-overlapping. And so you'll have debates where the string theorists say, well, can you calculate two graviton scattering? And the loop quantum gravity folks will say, well, no, but can you calculate the early universe? And so you have these debates that have that kind of character, which partly just reflects how little of our theories we actually understand. And so disagreements have more of a character of what's important? What is it that would be the important thing for this field to be able to do? And then that ends up reflecting back on these more basic questions. What is it that you want out of a theory of this sort? Right. So I think that really runs in parallel with what you're emphasizing, that it isn't a conflict like the kind of conflict that the epistemologists are focusing on, where we just disagree about something. It's a different, really different form of disagreement.
Yeah. So I think that's absolutely right. And so, as I spell this out further, I want to try to capture exactly the sort of worry that you have, which is that, disagreement in many of the contexts that we're interested in is actually a very highly variegated thing, right? It isn't just a matter of, people having different doxastic attitudes towards a proposition. It turns out to be much richer than that. And, this contrast between relatively transient and relatively stable disagreement is really kind of a blunt instrument, right, for just actually getting into the kind of spectrum of cases in which we might illuminate, right, some of what it means, right, in different cases where things are really unsettled and we're trying to get at them, where things are relatively settled. And I think it needs to be refined to do justice to the nuances of the kinds of things that you're describing. I think what's crucial, perhaps, for the moral that I want to draw at the end is that in contexts of public education and considering the import of the testimony of scientists, right, the authority of science and reliance on scientific expertise, right? It's too easily undermined, I think, if people don't appreciate that there are things that are being achieved by science, even in cases where there are the sorts of interpretive problems that you suggest. And that's part of what I was trying to get at the end when I said, the logical empiricists, I think, understood this very well, right? There are different kinds of cash value that you get out of scientific work. And some of it, right, might be shedding light on precisely these fine-grained interpretive issues that you're mentioning. And we may not be in a position to do that yet in some cases, and we may in others. In other cases, we have really good calculational devices and predictive devices, even though we don't really know what's going on from a fully specified ontological point of view under the surface. We have simulations that we use where we don't even think that the parameters of the simulations bear any relation necessarily to the phenomena, right? At least not on a like every variable corresponds to something in the world sort of way. But we know that they're highly effective at making certain predictions. Like, so Monte Carlo simulations are like that, right? So that's a kind of cash value as well. And I think that if we have a better understanding of the range of things that we're getting from science, then when a science denialist says, look, scientists working in this area of cosmology, they don't even really know, right, what's going on with these strings, or they don't really know what's going on here. It should be, ideally, hopefully, right, less easy to hoodwink people when we're able to say, yeah, that's the case, but here's the cash value I need from the relevant scientific theorizing so as to make policy concerning, problem X. And that those two facts are compatible with one another, right? The first shouldn't be a source of skepticism about scientific authority generally.
So I was going to have a brand new question, but it's turned into a follow-up, and I haven't changed my question. It's kind of fun. So I'm an applied mathematician, and I've done a lot of work in numerical solution of differential equations. And I was going to tell you about an example of a place where people disagreed, and being one of the parties, I believe at least one of the parties is rational. In fact, I believe the other guys are rational too. It's kind of interesting. So the theory is as much a knowledge that as it is a knowledge how. It's a knowledge of the complexity of the computational complexity of the solution of differential equations numerically. Because most differential equations you can't solve analytically, and so we just ignore those kind of cases and say we want to have methods for solving these things numerically, and we want to be able to assess the reliability of the resulting solution because we want to be able to say whether it's really true or not. So the information-based complexity group managed to come up with some results which proved that the numerical solution of differential equations was of exponential cost in so complexity. The fastest possible algorithms would be exponential in the number of bits of accuracy that you wanted. And they also proved that adaptivity, taking large time steps when you could and small time steps when you must, had no value asymptotically. And the general community just went, really? No, that just does not fit our experience. We can solve differential equations on calculators, so exponential cost doesn't seem to be a reasonable model for this. About 20 years ago, I came up with an alternative model, and my student, Sylvana Lee, she's now professor at Ryerson, and I proved that with our model, the numerical solution of differential equations is we have an algorithm that is polynomial cost in the number of bits of accuracy, which proves that the complexity must necessarily be no more than polynomial. So there's a fundamental disagreement in the complexity of the solution. Our model fits practice better, but in fact, when you take the asymptotics far enough, to the precision high enough, actually the information-based guys tend to have a little bit more of a point there. And if there's lots and lots of singularities, we have to locate each of those singularities. We can do them again with polynomial cost. But if there's a lot of them, maybe it's not so much fun. So here's a case I want to say in contrast to neuroscience, which is for Mike's question there, where everybody believes that the methods are as sound as you basically can get, and yet we still have a case where there is actual disagreement. So you may wish to use that in the future, but also pertains to what Chris was talking about, because we have to use these kinds of tools to give an account for whatever theory that we have, because frankly there is nothing else.
Right. Well, that's a really nice example. Thank you for that. It highlights, I think, one of the ways that it's possible to try to spell out the moral that I want to draw at the end, which is that the cash value, to use that expression again, in contexts where we're actually trying to decide how to act or what to do, right, or which problems to solve and how most efficiently to do that, are going to be pragmatic in most cases, right? I mean, if we know that we have successful techniques for doing certain things, for the purposes of making predictions that are going to inform how we should do things, right? That's all we need, right? And it may turn out that underlying that pragmatic efficacy, there are further things we want to say about which is the right way to go and which is the wrong way to go and why, right? But that, from the point of view of a lot of the work that we want to do in the public domain, is kind of supererogatory, right? And it's not to say that it isn't really important to people like you and me, because it is really important to people like you and me.
Without this kind of pragmatics, we don't really have anything, really. But, yeah.
Anjan, did you have a question? Yeah, I wanted to ask whether the temporal dimension plays a role in your argument. So if people disagree for a long time on the issue, do you make the disagreement less rational?
That's an interesting question. So did you have a particular case in mind of a long-standing disagreement?
Not really. I mean, philosophers disagree.
Yeah, right. Yeah, well, that might answer the question. No, I mean, I do think that there are...
so when the disagreement, there's discordance and it lasts for a long time, maybe you realize, well, maybe we didn't put the question very nice to be answered by this evidence.
Sure,
but
sure.
There are cases where the evidence on a particular question is discordant.
Right, right.
And then you realize it's because we didn't set the question very
well.
well.
It's an interesting question. I guess, how we might want to answer it might depend on further details of the case, right? So we can imagine a situation in which there's long-standing disagreement. One of the major contributors to there being long-standing disagreement is that the evidential basis we have for theorizing about the relevant phenomenon is so sparse or weak, right, that we don't really have much to work with, right? And so then we have disagreement, but we also don't have very powerful evidence, and we don't have very powerful inferences from the evidence, right? How worried should we be about that? Well, maybe not very. Right? On the other hand, you could imagine cases in which we have conflicting views, each of which generate different sorts of predictions, but that we aren't yet able, or perhaps may never be able, to actually test, right, in an empirical setting. Right? That seems a little bit more worrying, right, because they are actually making different claims about the world, but we're not in a position to bring in further evidence to try to assess what's going on, right? Then there are cases which came up yesterday when we were having a chat, in which we do have opposing views about a particular phenomenon, and we are able to generate evidence that really comes down on one side as opposed to another, and then the people whose view is seemingly refuted are stubborn and irrational and refuse to accept the consequences of their having been refuted, right? And that's an extremely worrying situation because it's very difficult to argue with people who are irrational, right? So I think that there are a variety of ways that we might spell out the situation you described, and I think depending on how we spell it out, it may be more or less worrying.
Thank you. I wanted to ask a question about whether we can do something about resolving the disagreements between two epistemic fears. Especially, well, first of all, I'm assuming that it's a good thing that we resolve disagreements, but that might not be the case. But according to this view where some disagreements might come from having two different stances, I don't know if people can argue about their stance or it's not being propositional, maybe you cannot even express it somehow. But I was thinking of the example that you mentioned, how, for example, the disagreement on the existence of the Higgs boson was resolved, and that was resolved by additional data, right? So is that how disagreements can be resolved? It's like trying to gather more evidence for one or the other side?
I think it can be, right? And that's a good case where, as I said, the kind of range of doxastic attitudes, at least among the relevant community of physicists, kind of collapsed in one direction after the acquisition of further data. But I don't think it need be the case, right? And that's because I think that some of the interpretations that are fueled by different epistemic stances aren't really turning on the amount of the data that are available, right? So if you take the contrast between people who are in what they would describe in a sort of principled way, right? More cautious when it comes to making claims about the properties, the natures of certain kinds of entities, say ones that are unobservable, even if putatively detectable, or ones that are not detectable but that play important explanatory roles in our theories. If you have a principled aversion to that, if you think, look, what I most care about is the empirical consequences of the theory and being able to work with those so as to do things in the world, and the concomitant lack of interest, right, that you have in whether the precise details of the underlying theory or theorizing are true or not, leads you to, it would take something extraordinarily impressive for you to be moved to actually, believe in some of those things, then, the addition of data probably isn't going to help very much, right? Because you have a kind of principled attraction to a more conservative or more cautious epistemic stance. So I think in some cases, if people are amenable to forming belief in a certain area, then the addition of data can help. In some cases, if they're not amenable, it won't. So I think one of the things that epistemic stances do is actually draw lines between domains of theorizing in which people think that coming up with warranted belief or, ultimately associating a truth value with the relevant descriptive propositions is even something that's on the cards, and domains in which it really just isn't on the cards. I mean, these are just domains that in principle we should remain agnostic about. And in those kinds of cases, right, if you've divided the domains in which you think belief is possible, even if you don't have it yet, but you think it's possible, and domains in which you think it's, it's really not on the cards, then no amount of data is going to convince you to assert things, right, in those latter domains.
You've sort of answered, that was going to be my question on Higgs boson, but you kind of answered it, but I just want to...
I'm trying to answer everyone's question just before they ask it. All right.
My question was going to be, to what extent would the Higgs boson example illuminate grounds in... I got to be careful, I put... grounds in at least applications for having evaluation of stances. So you could actually say that, and I think if you think of the pragmatic part, it might very well be that the Higgs boson would be a good example where you could give the... Okay, I should let you do it.
No, you do a little bit more, Bill, and then
on how the pragmatic part could come to bear on generating. I gotta be careful. I don't want to say standards, but something critical assessments of the. In this case, it would seem to be that you might. Okay, no, I better stop.
Standards is good. Like 5 sigma is a standard. Right?
Yeah, but,
That would do.
okay, but I just want to, yeah.
yeah.
I mean, what can we learn from especially that example, because it seems like such a clear one where you think that the sensible people are all going to go. But, yeah.
Yeah, well, first thing I should say is that I think I answered that question the last time around.
Yeah,
Yeah. No, I don't think I did.
That's the way you were talking about.
Yeah. So no, I don't think I did at all. So I do think that the pragmatic dimension of this is something that is closely related to something that I know you're very interested in, which is the idea of acceptance in domains like this. So why is it that I was able to say that the relevant community of scientists were committed to this, that they regarded it as basically correct, even though there may have been a kind of spread or a smear of doxastic attitudes towards this particular part of it, right? In virtue of what does that description even make sense, right? And it makes sense precisely because they were all committed to it. And the basis of that commitment is ultimately always going to be something pragmatic, right? It's what they can do with the theory, both, in terms of not only experimental success or application in various domains, but also the kinds of theoretical things that they can do. They can offer certain kinds of explanations that they couldn't otherwise, right? They can do certain kinds of theorizing that they wouldn't be able to otherwise, right? All of that I take to be part of the pragmatic benefit of having adopted that mathematical framework, which is, is incredibly rich and allows you to do all kinds of things. So then the question is, isn't it interesting how, that's not a question, that's a statement. Isn't it interesting how with that basis, right, people end up drawing very different epistemic morals, right, from the adoption of this common framework. So, there's definitely something that's shared, right? And it has to do with this idea of acceptance. But then how you describe the epistemic component, right, of that is going to vary among people who are actually part and parcel of the same research program. And that's in part why, I want to say elsewhere that the scientific practice itself kind of underdetermines the precise epistemic interpretation of, the content of the theory or the model or what you have. The reason it's a shared commitment is precisely because of all the pragmatic virtues of, operating in that sphere or having that model or theory as your working, right, paradigm or your working, your operative set of principles for approaching that part of the world. I don't know whether that answers your question, Bill, or whether the other answer was better. Right.
I think one of the, I guess I want to slightly push a Howard Stein thing to put in among the things. One of the things that he thinks is really important about acceptance is, or about what the theory is an instrument for, is for getting a better theory, is for actually leading to something that would overturn it and lead to a more fundamental theory. And that's sort of one of the things that that's part of the pragmatics, but that's something that you weren't putting in your way of talking about it that would be.
Yeah, I think that's really important. So let's take that as read. Yeah. That should go in there too. Okay.
Any other questions? No? Well, in this case, I'd like to